for future reference. So thank you everyone for joining us. We have 4 distinct learning objectives for today. The first is to learn how model work orders and work order standard tasks are used in the preventive maintenance process, to gain an understanding of all of the different PM scheduling processes that AssetOptics has to offer. Third, to learn how the due dates are calculated for each of the different preventive maintenance processes. And lastly, to learn how to set up PM schedules so that they can be pre-assigned to specific users or to a queue. So for the agenda, what we'll be stepping through is a preventive maintenance overview. We'll be talking about model work orders, and we will go and explore some of the model work orders. Then we're going to go into each of the 4 different types of PM schedules that are set up in the system. And those 4 different types are fixed interval calendar-based PM schedules, floating interval calendar-based PM schedules, meter-based PM schedules, and a new feature released in version 2.9 called PM group scheduling. And PM group scheduling is hierarchical preventive maintenance procedures. And that is where the parent suppresses the child PM procedure. And then we'll have a Q&A session afterwards. If you have a question, please be sure to enter the question into the question panel on your GoToWebinar control. And we will attempt to get through all of the questions at the end of the session. If not, we will certainly send emails back, on the individual questions. So again, thank you for coming. The first thing that we're going to cover is really the preventive maintenance process overview. So we have a combination on this webinar of existing customers as well as prospective customers. So I'm going to speak to both of those audiences. In AssetOptics, the preventive maintenance process is all predicated upon the creation of a model work order. That model work order serves as a job template. That model work order can be linked to many different assets so that job template can be used over and over, and then you specify what type of scheduling cycle that you want that to be released upon. That is the actual PM schedule. When you create a preventive maintenance schedule, you can manually release the work order off of that PM schedule, or the work orders can be automatically released using a scheduled job that runs in the background. Okay, so we're going to let's go take a look at a preventive maintenance procedure just to see a little bit more of the details. So we are in live software right now. This PM procedure that we're looking at is PM schedule number 49. The PM schedule IDs are system generated. It's linked to this model work order, this work order template, and this work order template is to perform a biannual inspection on a circulation pump, and it's tied to this particular asset tag. If we go down and take a look further at some information here, we can see that this job is to be done every 26 weeks. And this is a floating interval PM schedule. If this were a fixed interval PM schedule, this box would be deselected or it would not be checked. By default, the PMs are set up, when you go to enter one, it is set up as a floating interval PM schedule. If we come up here and take a look at a couple of other attributes, what we can see is this thing called a release window. And the PM schedule, just like all of the other page layouts within AssetOptics, all of the field definitions are specified, in the help. So you can hover over the question mark and read the help. So if we look here, the release window represents the number of days in advance of the PM due date that this PM schedule will be selected for work order creation. So in other words, the work order will be automatically generated and released 30 days prior to the due date right here. So the due date 6/23/16 and the work order release date is 5/24/2016. So on the morning of 5/24/16, a work order will be automatically generated for this one. We'll talk in a little bit more detail, but some of the other attributes that you can specify are a default user assignment. This will automatically assign this work order. There are some things that you can do in terms of overriding days. You can exclude Saturdays and exclude Sundays so that whenever the system generates and releases the work order, if it were to have been due on a Saturday or Sunday and you check these boxes, it will push it forward to the next working day, be it Monday. On every PM schedule, whether it is a calendar fixed, calendar floating, or meter-based, you can override the PM schedule by merely putting in a date. So let's say, for example, that we were going to do a shutdown, or we were going to have this piece of equipment available, and I wanted to pull this PM forward by basically 6 months, and I'm going to go in and I'm going to put a manual override date on it right here, and I'm going to save this. We'll now see that the PM due date calculates up to this date as it is overridden, and then I can, the system will either generate the work order tonight in the overnight batch run, or I can click the command button and generate the PM work order directly from it at this point. Okay, I'll come back and we'll take a look at that in a few more, and we'll release one here in a few minutes. There are different sections here on the page layout. There's a PM scheduling section for calendar-based PMs where you specify the calendar interval and the calendar interval unit of measure. On the PM schedule, this supports days and weeks for the scheduling interval unit of measure. We're going to look a little bit again at a PM group schedule, which works on months. If you have a meter-based schedule, all of the meter attribute data will be displayed here, and we'll come back and we're going to take a look at that in a little bit more detail, as well as one of the new features that you will see in the 210 release will be, and 210 is scheduled for release in approximately 2 weeks to get pushed, will be an overall work loading for every individual preventive maintenance schedule. So continuing along here, we see a couple of other work order references. We see current work order, and what the current work order represents is the last the last work order that was system generated from this PM schedule, and the last work order completed is the last work order that was completed off of this PM schedule. So if we look at some of the scheduling logic right here, we see that the last work order was completed 12/24. This is to be done every 26 weeks. So it calculates up what the due date is. We've overridden this, so I'm just going to actually null it out real quick. And we can see that it calculates 6/23/2016. Okay. Now, when you are looking at an individual PM, you can see the history of the work orders for just that preventive maintenance procedure, just that PM procedure. And of course, if you look at the asset record, you can then see all work orders for all work order history, be it for all different PM procedures and all corrective work orders associated with that. Okay. All right. If you wish to manually generate and release a work order, you can do so by clicking on the command button right here. And as I said earlier, we were just going to push this one out, and I can click Generate PM Work Order, and the in the system then generates a new work order. And if we go down here, we can see that this work order is in a ready to schedule status with a current work order due date of January the 30th, which is what we had put in as the override date. And now we see 2 work orders in the work order history. Okay. And you see some notifications coming up here in the email telling me I've got some work order assignments. So let's go back here and take a look and kind of move on a little further. Now, I said earlier that the entire PM scheduling solution is all predicated and built upon the notion of a model work order. So what is a model work order? Well, essentially, it's a pre-planned job. If you are familiar with other CMMS EAM solutions, sometimes you hear them called job plan templates. Sometimes you just call them job plans. Pre-planned work orders. I think model work order is also a fairly common notation. So a model work order is a pre-planned job that consists basically of 2 things: a set of work instructions and planned parts and supplies. The work instructions can be fairly simple. So for some of our customer base who has a smaller number of maintenance technicians, you can make the work instructions very simple, and you can write those instructions as essentially free format text on the work order header, or you can make the work instructions a bit more complex with many standardized tasks and planned hours and unique instructions, all applied at different craft levels. So let's go take a look at 2 examples here. I'm going to click and we're going to go to a simple model work order. So this model work order is a monthly safety inspection on a patient lift, so healthcare type of environment. And the extent of the work instructions are contained in the scope of work problem description field right here that says review operator's log to see if problems have been noted, gives you a few items to perform right here. And then you could log notes you could log any type of notes in the completion notes or as an individual note on the work order. We can see here that there is only 1 work order task associated with this, and it has 30 minutes or a half of a planned hour to perform this, and there's no predefined craft assignment associated with this. So simple environment, and there are no planned parts on this work order. So again, very simple model work order. When you go to create the model work order, you can see that the only thing you have to do is give it a title. It really does not have to be linked to an asset group. That's just something to help you organize with, and you can write the instructions, and then you can then go link that model work order to any PM procedures. Okay. So what happens whenever the system generates a new work order, it essentially clones this one. So even though this is not tied to, even though I'm not doing this from a PM, you can actually just go to any model work order and clone it. So in addition to the model work orders being for preventive maintenance procedures, they can just be predefined jobs that are performed on an ad hoc basis whenever you need them. So I just created a new work order, number 1516, that was referenced from this model work order 671 right here. And you can see that this is basically a duplicate of that work order. It's a duplicate of that work order. So let's go back, and now let's take a look at a more complex model work order. We'll link directly to it. And here is one that we have, and this is for a biannual PM for a circulation pump. And what we see here in the scope of work in the problem description is essentially biannual pump PM as per detailed instructions on the work order tasks. Well, if we now go down and we take a look at all of the different tasks that are associated with this model work order, we can see that we have 5 different tasks. We have a task that is derived from a set of standard work instructions for monthly pump task, and we can see that the instructions here are 3 items. Check the pump for leaks, visually inspect a drive coupling, check the oil level from the sight glass, add if necessary, log oil addition onto the work order. And this is designed to take a quarter of an hour and requires a minimum of this type of craft, Maintenance Tech 1. We have a second task here, which has the quarterly tasks, and that's another 15-minute task. We have a third task, which requires an electrician. And this takes 0.75 hours, and this is to perform a MEG test on this electrical motor. And yet we have a set of annual tasks that are bundled in here, change the oil, and we have a set of biannual tasks that are bundled into here also to replace the vibration dampening motor mounts and some vibration isolators that are on the suction side and on the discharge side of the pump. This one, of course, has then parts, because as you read here, there are specific instructions that says to replace items, so those will be parts that are needed. And we can see that we have the parts reference, and we have a planned quantity specified on these items. We need these vibration isolator motor mounts, 4 of them. We need this flexible hose, 2. We need oil, and we need 1 each. We can clearly see here what our on-hand quantity is and the primary bin location where those items are kept. So when this type of work order, when this work order, whether you just go to the model work order and create one, or whether it's automatically generated through the PM scheduling process, when this work order gets cloned, then all of these work order tasks get copied and all these work order parts, and we can see now that I've got work order number 1517 that's sitting in a ready to schedule status. And all of the parts that are on here now place a demand on inventory because we've got commitments for the inventory, which will then drive the automated supply chain replenishment process. So we've seen examples of simple model work orders and more complex model work orders. And the parts on those work orders can be referenced, or they can be reference parts, or they can be designed to be committed. And if we go take a look at something here, we're going to edit not this work order task, but rather the work order parts. And if we see that there's a flag right here that says commit inventory, if that flag is checked, then the parts get committed. If it's not checked, then you don't have it commitments, and it's essentially just a reference part. So one thing to consider, and that is, given the fact that there can be many tasks on a work order, is the approach that you take when you structure model work orders. So we support either method. So you can create a work order, let's say monthly, quarterly, semi-annual, annual, of the model work orders, and you can have many tasks on there, each with the typical instructions that would be done during that cycle. or you can just have a unique task, and that particular task is cumulative of all of the prior instructions. So now, what are the different types of PM schedules that we offer in the system? Again, fixed interval calendar-based PM schedules, floating interval calendar-based PM schedules, meter-based PM schedules, and PM group schedules. This is something new. All of the different types allow you to do some pre-assignment at the PM schedule level if you want to do some automated job assignments. Now, fixed interval PM schedules. It is very important to understand the difference in the scheduling logic between fixed and floating, because that determines which ones you apply to your specific business problem. For a fixed interval PM schedule, the due dates are calculated using the due date for the prior work order. Okay, so if we have due dates that say every 14 days or every 7 days, then the next work order is due by taking the prior work order and then adding the schedule interval to it to come up with a new due date. You take the due date, and you subtract from it the release window, and that gives you the release date. It is important to note that on a fixed interval PM schedule that you can have duplicate work orders for the same PM all open at one time. So with fixed interval schedules, there is no variance. You get no variance. So the system will just keep generating work orders. It will just keep cranking out work orders even if you don't complete the prior ones. So how do you specify a fixed interval PM? Well, it's rather easy. You deselect this field called floating interval. You deselect the floating interval field. And again, it takes the calendar interval in unit of measure and it adds it to the due date for the preceding work order to get to the due date for the next one. So what is the applicability and when would you use fixed interval PM schedules? It's all the PM schedules where you don't want any schedule variance, okay? Where you don't want any schedule variance. And now with the release of 2.9 and what we've done for PM group schedules, the fixed interval PM schedules really are best applied to things like daily checklists, weekly checklists, or any other fixed interval scheduling that is less than a monthly, that's less than monthly on the frequencies. Floating interval PM schedules. Now, floatings are a little bit different than fixed interval PM schedules. A floating interval PM schedule, the due date for the upcoming PM schedule is calculated from adding the scheduling interval to the completion date for the last work order. So let's say that we've got this work order, we've got a work order, okay, and that work order would have been released in, early because you have a release window on it. Now, if you complete the work order before the due date, then the next one gets scheduled by taking the completion date and adding the scheduling interval onto it to come up with a new due date. If you complete the work order after the due date, well, then it takes the next one and it pushes it forward. So it takes the scheduling interval and adds it to the completion date. So it's important to note that for floating interval PMs, if the work order does not get completed, that work order will sit open in a delinquent status and no new work orders will be created. It will just sit in your backlog, delinquent, and a new work order will not be created. So if we go here, let's go take a look at a floating interval PM. I'm going to show you an example right here. So we've got this job right here that the last work order was completed on 10/28. On 10/28, so we've added 13 weeks to it to come up with a new due date of January the 27th. We put a 14-day release window. It means it's released on the 17th. This work order was already created, and it's work order number 1514. It's due yesterday. So let's just say, as an example, we're going to go ahead and change this to a completed status, but we're going to go backdate this a little bit, and we're going to say that we finished this on January the 1st. And we're going to save this. So now if we look here at this one, it tells us that it's due on, the next one is going to be due on April the 1st because it's a floating type interval. If we were to go to this work order and we were to adjust this completion date, and let's say we're going to push this up by a month, and we're going to push this completion date on that work order up by a month, and oops, let's say that we completed it here. I'm trying to show that I completed it in the future. So we're going to do it on the 22nd, so we can now see that the schedule pushes forward. Okay, so this is what a floating interval does. So a floating interval, the PMs have cumulative variances, if you will. The next one is due based upon when the prior one was completed, and you add the scheduling window, and only one work order is due at a time. Meter-based PMs. Now, the meter-based PMs, this gets to be a little bit more complex, if you will. Meter-based PMs, the due dates are projected from the meter readings that you put into the system. Okay, so if we took a look at a meter-based PM schedule, what you see is a PM schedule. You link it to an asset, you select a meter, and when you go to select that, it only shows you meters that are tied to that asset. However, you can clear that filter, and you can choose a meter that's on any asset. So when you build an asset hierarchy, you can choose a meter for the parent record and propagate that down through the entire hierarchy for preventive maintenance scheduling. So in other words, you can schedule PMs for components based upon the parent asset. What a meter-based PM schedule does is it takes your historical readings and it projects those into the future. So let's look a little bit more, and we'll explain and get an understanding for how meter-based PM schedules get calculated. When you complete a work order that was generated from a PM that is a meter-based PM, there is a field on the work order called meter reading at work order completion. Meter reading at work order completion. So as an end user, when you complete that work order, you can put in the current meter reading for the asset, and it retains that meter reading on that work order. If you do not enter a value onto that work order and it was based upon a meter, then the system logic goes and grabs the last meter reading that was entered onto that asset, and it defaults that. So from a best practices perspective, whether you are on a browser, whether you're on a mobile device, a good practice, you can, if your meters are not being updated on a very frequent basis, even on your mobile device in Salesforce One Mobile with AssetOptics deployed to it, you can on the work order select the asset and then enter a new meter reading directly, at that point in time. Or of course you could just enter it at the time that you complete it. So the meter reading at the work order completion gets stamped onto that work order, as does, of course, the completion date. Then the next PM will be due by taking that meter reading at work order completion and then adding the meter schedule interval to it to get the PM due meter reading value. So if we go back here and we look on the screen, we will see here, this is called the PM due meter reading value. So this job is to be done every 5,000 hours. It's due at 16.5, so that should tell us that it was last done when the meter reading was 11.5. If we drill into the software and actually pull up that specific PM, let me close some of these tabs here, and we pull up that specific PM, let's collapse this and let's expand this section, we can see here that, that this PM schedule right here is to replace a set of wear strips on a dissolved air flotation tank. Here's the model work orders tied to this particular asset. We can see that the PM due date is March the 1st, 2017. We got a 15-day release window, and it's going to be pre-assigned to maintenance technician number 3 right here. Okay, we're going to collapse that calendar-based scheduling section. This is set up to schedule by meter. It's tied to this meter right here, and it was the last work order was done at 11,500 hours. Add the 5,000 to it. It comes up, says it's going to be due at 16,500. Now you'll note here that the last meter reading date is being retrieved from this meter right here, meter number 1. The last meter reading date was January 19th, 2016, and the value when that meter reading was done was 12,260. That differential, the 11.5 to 12,260, represents 15.2% of that 5,000 hour interval. Okay, so what the system is doing is it's calculating. So let's look at this meter reading number 1 right here. It's looking at that run rate, and then it's projecting out into the future when it will accumulate those number of hours, and then it calculates what will be the date that happens, and that's what's called the meter-based projected due date. The meter-based projected due date. If we look here, this is what this says, the meter-based projected due date. Okay? And as you continue to enter meter readings into the system, you begin to reduce the number of hours that are outstanding. In other words, you are increasing this value right here, the meter interval percent complete. Of course, when the meter interval percent complete reaches 100, that means you are all the way up here, okay? So it's 0 to 100% along here. And as you get closer in and closer in, fundamentally what you're doing is you're reducing the uncertainty and the variability for projecting the actual due date. So when we set up the system, by default, there are 2 parameters which you as an end user can change. And what these 2 parameters define are how close to the full percentage of the meter readings do I have to get into, and how close to the actual projected due date do I have to get before the system releases that work order. So if you have a very, very short planning cycle, you can make that very tight. You can say, when I get all the way up to 95% of the meter reading, I can release it at 95%. Or if you want a bigger window, you could say, when I get to 80%, I want to go ahead and release it, and then I'll schedule it, based upon that projected due date. And then we'll kind of revisit it when we get down to those last few days anyway, because maybe a 10% variance in the meter reading, isn't that material. Okay, so that is all configurable, based upon, based upon your business needs. So if we went and as an example, we can see here that this one is due on March the 1st, 2017. So if we go to this meter right here, meter number 1, and we put in a new meter reading, so let's go in and we're going to put in 13,000 on here, and we're just going to say right now, we'll let it default to today's date and time. Then we go back and we look at that PM. Now let's take a look at the impact upon that one. We have significantly reduced the amount of usage, or rather significantly increased the usage here. And now this due date is being recalculated and is saying it now, if you keep using the asset at this particular run rate, this PM is going to be due on August the 6th. And again, as you get closer and closer in, you will be able to better refine. The uncertainty and for the particular due dates. Okay, so let's get back to here. Couple of things to kind of take into consideration. There are two different types of meters that you can utilize in AssetOptics. There's something called a cumulative meter and a counter. The cumulative meter is a meter where the meter readings that are being entered have to be greater than the last meter reading, because you're moving forward in time, in distance, okay? So those are things like odometers, hour meters. So it is always an expectation that when you're entering odometer readings, that those odometer readings are increasing, unlike Ferris Bueller's Day Off, when you jack the Ferrari up and throw it in reverse. There's something called a counter. And a counter is a meter where it's reset back to 0 every single time that you go to put in a reading. So that might be something like a production counter, a unit counter on a piece of production machinery or a production line, or the amount of fuel added to a vehicle. So there's a number of things that you can use the meter for, even if you don't use it for tracking, even if you don't use that meter, let's say a counter meter for doing preventive maintenance scheduling. If you wanted to keep up with the cumulative amount of oil that has been added into a gearbox on a paper machine or something, every time you add it, you could go enter that amount onto that particular meter tied to that asset, and then you could look at that usage over time. Same thing, like in a transportation environment, whenever you get your fuel card, your fuel your fuel card information that gets downloaded, you could import that data and then add all that and then look at cumulative fuel usage. Meter-based scheduling is really applicable for all usage-based scheduling, all usage-based scheduling within AssetOptics. And big consideration, meter readings have to be entered on a routine basis, whether you have it done in an automated fashion or whether it requires that you manually enter. Meter readings have to be entered in. Lastly, we're going to talk about PM group schedules. So PM group schedules is a new feature beginning with release 2.9, which is the current release. And they're with 2.9, and there's some additional enhancements added to PM group scheduling in 2.10, which will be available in approximately 2 weeks. 2 weeks is when we should push up the new package and make it available for an upgrade for you. So with PM group schedules, these are interdependent. They're parent-child relationships. It's like a hierarchy. And what happens is the higher level intervals will suppress the lower level intervals. So in other words, if you've got a 12-month interval, it'll suppress a 6-month interval. That 6-month interval will suppress a 3-month interval, which will suppress a 1-month interval. Okay. The other thing is that you can be much more granular on the group schedules when you can specify a day of the month or a specific weekday permutation when the work orders are going to be due. Now, this is a fixed interval scheduling logic because we are specifying the day of the month or the weekday permutation. So this is a fixed interval type of scheduling logic. And you can have multiple work orders open for a single PM schedule, for a single PM group schedule, all at one time. So here's essentially how this looks. So there's a new object called PM group schedule, and you link, and the PM group schedule is system generated. The ID system generated, you link an asset to it. You don't specify the model work order up top, you just specify the asset. You then determine on what day for that group of PMs is this going to be due. And again, and we're going to jump over and show you how to change this in a live screen. But you specify day of the month or weekday permutation. You then can create many details to this. This is essentially now where I go and I assign my model work order and I specify the monthly interval. I specify my model work order and the monthly interval. And if we take a look at this configuration right here, I have a model work order number 1222 that's to do a monthly PM, and the monthly interval is 1. I have 1223, which is a quarterly interval, which is quarterly PM, that's to be done every 3 months, and then every 6, and every 12, and every 24. So if we look at the timeline, what the system does is, and this really represents the beginning of the month, the bubble here, the circle. So within that month, you then specify again the day of the month or the weekday permutation. So what this would do is it would generate a monthly, and then the quarterly, the monthly, and then the semi-annual, the monthly, the quarterly, the monthly, annual, and then back to monthly, and then as this repeats its 12-month cycle, then instead of this annual, it would be a biannual, and then everything resets and starts over. One of the features that's added here so that it simplifies when you set everything up so that you don't have to go manually set all these dates, it is not assumed that when you set up a PM group schedule that you are at the beginning of the scheduling window so that the biannual isn't 24 months out from today. If you look at this as a 24-month cycle right here, a 24-month cycle, when you go to set the PM schedule to an active status, you can specify what is the starting month in that 24-month window, and it will then calculate. So if this is a starting month of 2, when we went to make these active, what that means is that this 24-month is due 22 months out from now. This 12 then in turn means it's going to be due 10 months out from now, and the system calculates all of that, and it figures out, do I need to actually push out a monthly or a quarterly this month, or whatever. If this were a 3, then the very first month it would be generating the quarterly. So let's go take a look at that in detail and go look at the go look at this in software. We can see here that we've got, this day or weekday of the month here. I'm just going to double click, and these are all dependent. So I can say the day of the month. So I can choose anything from the first day of the month, the 15th. I can choose any day, 1 through 31, or I can select last. Last is basically the same logic as 31. Because if you select 31 and there's only 30 months, 30 days in the month, then it will make it on the 30th for the months with 30. If they don't have 29 in, leap year February, it'll make the last equal to 29, or if it's 31 or 30. So fundamentally, last is the same thing as 31, 30, 29. And so I can select any specific day of the month. I can also select a weekday of the month. So if I choose weekday, I can say on the first, second, third, fourth, or the last. Okay, so as we in the South in the SEC country, we like to say on the third Saturday in October. So you can specify a weekday of the month. So again, if we want to say on the first Monday, we want all these work orders to be due on the first Monday, then they will all calculate, and that is across all the intervals for that specific day, okay? Now, pre-assigning preventive maintenance procedures. For a PM schedule, whether it is calendar fix, floating, or meter-based PM schedule, if you enter a default user assignment, if you look up a user record and add that user to the default user assignment, then when the work order gets created, the record owner will be the default user, will be this user specified in the default user assignment. They will be the record owner, and they will also be the person, populated into the default user assignment. Now, if you don't put a value in here, and this is a very important thing to understand, if you don't put a value here, then the record owner will be the record owner for the PM schedule. The record owner will be the PM schedule record owner. So when you have a multi-site implementation, you can utilize record-based security to isolate visibility across the enterprise. If it's a PM group schedule, it works exactly the same way, except that default assigned user is on the PM group detail record. So if we went and we took a look at one of these, the default user is on the detail. It's not on the header. So that way you could have a single lead person assigned for every one of these details down here. Now, if you don't assign a user, then the work order record owner will be the PM group schedule record owner. And it's because of the logic of the group of the record owner that allows you to do something like assign to a queue. And if you're not familiar with what queues are essentially a named group of users. So if you want to do queues, if you want to have all of your PM work orders assigned to queues, then what you do is you enable the queue, that specific queue, on both the work order and the PM schedule. Then you make the PM schedule or the PM group schedule record owner equal to the queue, and you do not enter a defined user on the PM, on that PM schedule or on the PM detail. You don't enter it, and then when the system generates the work orders, the record owner will be equal to the queue, and then people can draw from the queue. So just to kind of recap what we've talked about here, is we've learned model work orders and how the tasks are assigned and used in the PM process. We've gone through the 4 different PM scheduling processes: calendar fixed, calendar floating, meter based, and PM group schedules. And very specifically, we talked about how all those PM due dates are calculated for every one of those, and also how the PM schedules can be pre-assigned to specific users or to individual queues. This webinar will be posted on the AssetOptics YouTube channel, and if you have any questions, please enter those questions in the GoToWebinar panel here. And I see that we have quite a few of them here, so I'm just going to kind of go through. We're going to kind of go through these. There's a question here. One work order per PM. A PM is linked to a specific asset, and thus there is one work order generated for that unique for that unique event of performing that. And you can have many work orders in the history for that particular PM schedule. There's a question here. If you put in an override date, does the original date resume, or does the next one changed on the calendar-based PM schedules? Well, the fixed interval and the floating interval PMs behave differently. If you put in an override date on a fixed interval PM schedule, it does in fact change the due date on the next one. So that's kind of an important thing to really understand also, is that you can do things like take a fixed interval PM schedule, you can go to that current work order, and you can just push the due date off way into the future, and it will never generate any more PMs. So that's kind of a way that you can just manually implement a like a blackout period. Same thing for floating schedules. Is there any special handling for daily scheduled PMs? Yes, there are. So for a daily scheduled PM, what you would do is you'd set up calendar fixed. You would make the PM, the schedule interval, equal to 1, and you'd make it days. It would generate a new work order every single day, and you have the option to check to exclude a Saturday or exclude Sundays, and it would automatically generate all of those. And then based upon your release window, so if you made the release window 1, that work order would be generated on the day before it's due for the next day. Or if you made it 2, it would generate 2 days prior. So if you made it 1, you'd always have 2 work orders open at one time, today's and tomorrow's. If you made it a 2, you'd always have 3. You'd have today's, tomorrow's, and the day after. How do we change a due date permanently when using fixed interval? You would basically go set the override. That's really how we would do it. Put in. Okay, so here's the so. During some data conversions here, there were many erroneous due dates that were populated. I will, for the person that's asking this question, I'll have our support organization reach out to you have Mike Holland reach out to you. There's a couple of different ways that it can be done through mass data loading, through the back end, and either put in override dates for everything, or we can go and back complete some prior work orders. There's a question here about meter-based scheduling and making the meter-based scheduling fixed intervals, and I can say for the individual that submitted this question, there has been some. I know your specific org. There's some unique configuration that has already been done in your org so that you can have fixed intervals on meter-based schedules. So here's a question on calendar-based PMs. On calendar-based PMs, that means I have 2 work orders after 2 months, monthly and quarterly, and then at 6 months we have 3 orders for quarterly, semi. I'll have to follow up on. There's a question here about the number of work orders that are open if they're monthly, quarterly, semi. It's really a function of whether you set them up as PM group schedules or whether you set them up as PM schedules. The regular calendar-based PM scheduling function does not have any type of dependencies built upon it. So if you have a job that's set for 13 weeks, one that's set for 26 weeks, one for 26, one for 13, the 26 does not, on the regular PM schedule, does not suppress the 13. So you would either have to reschedule one of those or cancel it. So there's a question here, can the system send out emails or text messages to those who have work orders assigned? Yes, they can. I think what you probably saw whenever some work orders were getting generated is that I was getting a Google email notification that was popping up. This question, is the mobile app able to manipulate the software as fully as the web-based interface? I will say, for all practical purposes, the mobile app will perform all of the field-related tasks that really need to be performed. That's the last question. Again, if you have any more questions, feel free to email myself, mike.edwards@assetoptics.com, or you can send an email to info@AssetOptics, and it will get routed into a group email box here. As I indicated earlier, this webinar will be posted onto the AssetOptics YouTube channel, and we will send a copy of the presentation out to all of those who attended. I want to thank you again for your time and participating on this webinar. Have a wonderful day.